This is code.org, and let's talk selection sort. Investigate and modify. Run the program to observe the results. Cool. All right, so 10 checked, 40 checked. I'm noticing a pattern. Total swaps are 4, and it looks like we got them in order. And it appears then that this would be the original array that we just sorted. All right, look at the selection sort method in sorter.java. What do you notice about the code? Add a print statement inside the if statement to print elements at the index next. This is a big guy. All right, so regardless, we want to add a print statement to print the element at index next. Okay, so I did, and we only needed the next index value, but I also did the index. I wanted to know the number of it. 3 value, okay. So notice when this if statement is true. If and only if the current data.next, is less than the current value. So we're looping through then and comparing, right? We're going through the entirety of our array and we're comparing the values at one point in the array to another. And then if one value is less than the other, that's why we have a nested loop here. We go from the front of the array to the end, checking each item. And then when we find a data value that is less than what we have stored, so right now, if the next value is less than the current value, what is our current value? Our current value is set at the beginning, right? And what it is, we're looking for the lowest value. So I actually don't love that it's current, but it's possible lowest. And we loop through till the end of the array, and we check the value against each other, each value against each other, and then we find whatever data is the lowest, whatever value is the lowest, we move to the current index. This sounds complicated. So, graphic. All right, so to start, I'm going to look at number 3. We have 2 quote-unquote pointers. One is here, or 2 loops, right? One is here, and then the other, I'm going to move around. So I start by looking at the 3. Now, I'm also, in my nested loop, going to go through the data. Here, I look. 4. Is 4 less than 3? 4, and keep in mind, current right now is 3 because it is set before the second loop. 4 is not less than 3, so current is still index 0. 2. Is 2 less than 3? Yes, 2 is less than 3. So current is now index 2. Or yes, 0, 1, 2. 5. Is 5 less than 2? No, it's not. 1. Is 1 less than 2? Yes, it is. So current is now index 4. And we're at the end. So what we do at this point is we flip-flop. I switch index 1 and index 3. And now I start all over again. This time are not at this value though. Oh, that's a different blue. Okay. Current is at index 4 and I loop through again. Okay, is 2 less than 4? Yes, then current is now index 2, and then I loop again. Is 5 less than 2? No. So now 4 and 2 switch, and I start at 5. No, 4 and 2 switch, and I start at 4. Is 4 less than index 5? Or less than value 5? No. Is 3 less? Yes. These flip. Then, so on and so forth. Keep in mind, we always have 2 loops. So here, current started at 4, and we had a loop. No. Yes. And then here, once we switch those 2, our current will start at index 5, and we start looping through again. Every time we're having 2 loops. So, back over here, that's what's occurring. We're looping through the data and switching out the largest for the smallest. What do you think would happen if the array to sort was already sorted? If it's already sorted, that's the problem actually with this algorithm, is it still has to loop through all of the values because it's not going to know that. So it doesn't check first off regardless. Let's see, 21. And so this actually is I'm going to call my numbers 2. Boom. It still had to check 4 times. And the reason it does is it doesn't know. It says swaps, but really those swaps were putting 20 where 20 already was, 30 where 30 already was, so on and so forth. Which, if you're familiar with time, this is an O(n) squared sort. It is not super efficient, but it is really useful, and you'll see it commonly used throughout computer science. All right, let's see what else we're doing this. Onward.